Hello guys, welcome back to this channel. Okay, in this occasion, I S2 will be explain about what radian means. Okay, let's begin. Do you know this, and this? I believe if you know it. But how with this? Radians? What is the radians? And it is equal the degree? Okay, let me repeat. Okay, to understand what radian means, we need to draw a circle. Let O be in the center of this circle, and let R be in the radius. Now let me take the radius and press it. Blue segment will also be R. Now we just need to pass this blue segment from the top such as slice entirely on the circumference of the circle like this. The length of this blue part is still R. It has just become curve, that's R. The curve starts from here and ends here. Now from the center of the circle we draw another radius that joins another endpoint of the blue curve. This length will also be R as its radius. So let's analyze the figure. We have an arc of length equal to the radius of the circle, and the two radians are joining the center and endpoints of that arc. Remember, the length of the arc is equal to the radius of the circle. This angle falls here in 1 radian. Okay, that's the concept of radian. But actually, there's radians everywhere around this angle R, and R. That's probably why they call it radian. If you understand this concept well, then understand the convention between degrees and the radians will be a backward. Now let's try and see how can be written in the terms of another. We know the formula for the circumference of a circle is equal to PR, where R is the radius. Now observe the figure really well. The length of this blue arc is R, which is the length of the radius. We have the formula in front of us. Yes, we would need to be of such arcs. Since pi is approximately 3.14, we will have to multiply 3.14, which equals 6.2 xr. We will need 6.2 xr of length r. We have already drawn one arc, so let's try drawing more such arcs of the same length of the circumference. This is the second one, then third, a fourth, a fifth, a sixth, and some plus left here for 0.2 arc. It's equal 6 arcs plus 28% of the arcs, and as we saw, one arc corresponds to radians at the center. So how many radians we will full rotation over the center? Yes, one full rotation equals to pi radian at the center. It simply means that if we rotate one arm completely, then 2 pi radians we will be covered at the center. But wait, we also know that the one full rotation equals 360 degrees. From this to equal, we can say that 2 pi radians equal 360 degrees. Now it is very simple that to express one in the form of another. If 2 pi radian equals 360 degrees, then 1 radians equal how many degrees? 1 radian will equal 360 degrees divided by 2 pi. We know that to multiply by 180 is 360. Hence 1 radian will equals 180 degrees by pi. The value of pi is approximately 3.14. So this approximately equal 57.2958 degrees. Okay, 1 radian equals 57.2958 degrees. There are a few more things that we deduced from we just learned. To pi radian equals 360 degrees. This is actually full rotation. This is mean that an arm rotates completely in cover to pi radians if we divide it both sides by 2. We get pi radians equal 180 degrees, and 180 degrees is half circle or a straight line. The angle subtended by a semicircular arch. At the center is pi radians, and we can again divide it by 2 to get pi by 2 radians equal 60 degrees, which is actually its right angle. So right angle is equivalent to pi by pi radians. Okay, remember my explanation in above. 1 radian is equal to 180 degrees by pi. This is approximately equal to 100 degrees by 3.14 since pi is approximately 3.14. So solving this, we get 1 radian approximately is equal to 57.2958. 1 radians is just like any other answer in degrees like this. This is measure 1 radian, which is 57.2958 degrees. Okay, this is my explanation about the radian. If you have any question, you can write and comment in there.